Let's look at the compass as I was talking about. This is the compass showing the four main cardinal points: north, east, south, and west. North, east, south, and west. Take note of this. You learned this in social studies, right in the GSS. Now, when you want to represent angles, a three-digit angle, the first thing you need to know to draw is a simple compass. A simple one, not too big. Remember, this is your north, the east, the south, and the west. It is not mandatory for you to name north, south, east, and west. Write the names of the cardinal points on the compass. It is not required. What you should know is that this particular portion is the north, this is the east, this is the south, and this is the west. Now, in three-digit bearings, angles are measured from the North Pole in a clockwise direction. This is a clockwise direction. Clockwise direction. Angles are measured in the North Pole, from the North Pole, in the clockwise direction. So any angle that is given, its value is taken from the North Pole through this direction, through the right, as the clockwise direction, the direction in which the hand of the clock moves. It is a clockwise direction. A turn from the North Pole up to this point is exactly 90 degrees. You can see it here. A turn from the North Pole to this particular portion, north to this east, is 90 degrees. Now, a turn from the North Pole right down to the South Pole on this compass gives a value of 180 degrees. It's a complete turn, it's a turn of 180 degrees from the North Pole to the South. Then again, from the North Pole through the East, through the South, up to the West, gives a total turn of 270 degrees. 270 degrees. Moreover, a turn from the north through east, through south, to the west, and back to the north is exactly 360, a complete turn, 360 degrees. So you can see that a turn of 0 degrees and a turn of 360 degrees is exactly the same position. 0 degrees turn, you don't make any movement. You are here. A 3 degrees turn, you go around and still come back to the same position. So a turn of 360 degrees and a turn of 0 degrees is actually the same position. You should also know that from our discussion, if from here up to this place gives a total turn of 90 degrees, from here up to here is 180 degrees, you should tell that each box here represents 90 degrees. The turn from each cardinal point to the next adjacent cardinal point is 90 degrees. These two lines divide the whole space into 4 quadrants. So this place is 90, this place is 90, this place is 90, this place is 90. So a line in between here will be 45. Here we divide this place into 45, 45. So if here is 90, then a turn from here up to here is 90 plus another 45 gives 135 degrees turn. There is it. In between these two lines, you have 45 degrees here, 45 degrees here. So a turn from through this place up to this place is 180 plus the 45 give us 225 degrees. So a turn of 225 degrees, 225 degrees is here. Moreover, this line also divides this chamber into two, 45 degrees, 45 degrees. So a turn of 315 degrees, 315 degrees will be this position, because from here up to here is 90, up to here is 180, up to here is 270 plus the 45 will give us 315 degrees. So this relative position should always be in mind as you are doing your sketch. Now let us pick a question and look at how we are going to do the sketches. So represent the following diagram. Let's go to the first one. 0.45 degrees. Question number 2. Question 2. 125 degrees. 35 degrees, sorry. 135 degrees. 135 degrees. Question number 4. 200 degrees. Question number 5. 320 degrees. Let's do the question 1. As I said earlier on, you begin by drawing your cardinal, your compass. I know there is north, there is east, south, west. The whole of this turn is 90 degrees. So my 45 degrees turn lie exactly here. So I'll draw a line there. So there's a direction. Then I put an arrow on it to show the direction. I said bearings are direction, so always when you indicate the angle with the line, you put an arrow on it. Then you close this place with an arc. Write the value of the angle, 45 degrees in the enclosure. So this is the diagram for the first question. I hope it's not difficult. First, you draw the compass. It's not necessary for you to write north, south, east, and west. It's not necessary. You all know that here's north, here's south, here's east, and west. You all know that angles are supposed to be taken from the North Pole. So from the North Pole, we are taking a turn of 45 degrees. You know from the North Pole here, want to turn 45 degrees, you turn up to this point. 45 degrees. If you go beyond the middle, you are going beyond 45 degrees. With these angles, we can use protractor to measure them accurately. It is not bad. But it is also allowed for you to sketch. Now, when sketching, you have to be skeptical. You have to be, vigilant and read the sketch as well. For instance, if with this 45 degrees, if we place a turn over here more than 45 degrees, come down here, it's more than 45 degrees, or you place it somewhere here, it is less than 45 degrees. What will happen is that when it comes to distance bearing problems and you're not able to position your bearings appropriately, your diagram will lead you to make certain conclusions, to lead you to make certain judgments. So you must always, you cannot get the angle accurately when you are sketching unless you use a protractor. But there are certain positions when somebody uses the eye, by just using the eye without a measurement tool like the protractor, you can say he could not be able to detect that for this angle is not correctly placed. For example, this 45 degrees, if you place the 45 degrees here, if the naked eye, anybody seeing it will see that, oh, this for this 45 degrees is wrongly placed, or you should bring the 45 degrees here, because we know the 45 degrees should be in the middle between these lines. So we can't place it somewhere far away from the middle. It should be in the middle. That is what I mean. In sketches, you might not get it accurately as you want. The angles, you may not get them accurately as you want, but they should not deviate so much that the naked eye can see it visibly as one. Other than that, then you have to use a protractor to measure accurate angles. I repeat again, once you do wrong diagrams, they will, when it comes to distance bearing problems, after you draw the diagram, you analyze the diagram, do calculations based on the diagram. So once the diagram is wrong, it will lead you to make wrong assumptions, and hence all the calculations you'll be doing based on that assumption will be flawed. So that is it. Let us now look at how we're going to do the 135 degrees or 135 degrees. We're going to look at the 135 degrees. Let's put the question 1 aside and pick the question 2, 135 degrees. I beg your pardon. So I mixed a different color to differentiate this one, only first one. So I'll first draw my compass. I know from I turn from here up to this line. Sorry, turn from here up to this line is 90 degrees. So if I want 135 degrees, it should go beyond the 10. It should go beyond this line. It should come here, and it should not go beyond this place, because once it's going beyond this place, it's going beyond 180, and the angle given in question 2 is less than 180. And we know 135 is exactly between 180 and 90 degrees. So this is our 135 degrees. This is our 135 degrees then, from the North Pole and down to the middle here. From the North Pole right down the middle here is 35 degrees. It's 35 degrees. 135 degrees. And as I said earlier on, anytime you finish, don't forget, put your arrows on top. Then draw your arc from the North Pole up to the line. Wrong two. Draw your arc from North Pole up to the line at 10. Write the value of the angle 135 degrees. The arc you just drew. So that's question number 2. That's question number 2. Let's go to question number 3, which is 200 degrees. So I'll use a different color so what we already do. Now, as we know earlier on, you first have to draw a cardinal point. Your compass, sorry. This is my compass. I know a 10 from the North Pole up to this portion is 180 degrees. Up to this portion is 270. We know the mid portion is 225. That is 225 degrees. But this time around, we are looking for 200. So you should not lie in the middle. can come down small like this. Good. Don't forget, we have to indicate the arrows to show our direction. That's the arrow. Do you remember what will be done next? Yeah, you have to draw your arc and indicate your angle 200 degrees. 200 degrees. That's it. Let's do the last question. Then I'll give you an exercise to also try. I'll give you an exercise to also try. The last question. 320 degrees. As I said earlier on, you first have to draw the compass. After drawing the compass, then indicate the 10. You know that from here up to here is 270. Or we are looking for 320, which is more than 270. Remember the middle portion here is 315. That is 270 plus 45. But we are looking for 320. 315 is the middle portion here. But we are looking for 320. And we just want to go a little bit above the middle. So here we are going to do. Then what next? You put your arrows on the lines. After that hot next, you draw your arc like this after the line. What's the last thing? Write the value of the angle 300 degrees. So this is how we represent three figure bearings on diagrams. I hope you can also try. So in the next slide, I am going to show you, give you questions about 4 angles. You also represent them on diagrams. When the questions are displayed on the screen, please do as much as possible to pause the video. You draw your sketches and then you compare them to what I have